All right, good morning. Today we're continuing our review of quadratic functions. Today talking about standard form of quadratic functions. So standard form, if you remember, looks like y equals ax squared plus bx plus c. So standard form gives us a couple of the same bits of information. That a value is the same as it was in vertex form. So if a is positive, then the parabola opens upward, right? And our vertex will be a minimum. If a is negative, the parabola opens downward, and our vertex will be a maximum. The other bit of information that we get here from standard form is that c value. If we relate this to a linear equation, mx plus b, that b value is our y-intercept. Here, that's exactly what it is in a quadratic function. The value of c gives you the y-intercept. And the reason that is that if we were to replace x with 0, right, we would end up with two terms equal to 0 and then our c value. So just a small example here, 2x squared minus 3x plus 9, if we think about the information that we're given. So that a value is positive 2, which means that our parabola opens upward. So whatever that vertex happens to be, it is a minimum. And then we also know that our y-intercept here is going to be this c value. So we can write down that our y-intercept is the coordinate point 0, 9. And remember, I'm going to be nitpicky about coordinate points there. They are coordinate points. We should write them as such. Now, unfortunately, this just doesn't give us a ton of other information. We could take a stab in the dark with other x values that are nearby 0, but of course it would be way easier if we had the vertex. So if you recall, we can use standard form to pretty easily and quickly find the vertex of the parabola. So we start by finding the x coordinate of the vertex. Using the formula x equals negative b divided by 2 times a. And remember that negative b here is really short for -1 times b, whatever that b value is. And we're going to look at some examples there. You know that I prefer using parentheses here to keep everything organized. And again, I encourage you to use them. Once we have the x-coordinate of the vertex using that formula, we can find the y-coordinate, not intercept, but the actual y-coordinate of the vertex by plugging the x value into the equation and evaluate. So whatever we get as our x value, we'll plug that into the equation and then we will evaluate from there. So we're going to do an example here together, finding the vertex of this equation, negative x squared plus 6x plus 2. So my a value here is -1. My b value is 6. So when I use my formula, x equals negative b divided by 2 times a, that's going to be -6 divided by 2 times -1, right? I substitute all those values in. If I continue to reduce this, that's -6 over -2, which is positive 3. -6 divided by -2 is a positive 3. And then I want to substitute my substitute that x value in to find the y value. So that will be -3. And every time I replace an x value, I'm going to enclose it in parentheses. Again, dealing with positives and negatives along the way, parentheses are just going to be good friends of ours. So I substitute that x value in, right? I took that 3 here and I substituted it in as my x value. So I simplify, I'm going to get -9 plus 18 plus 2. And when I simplify that further, I'm going to get 11. So my vertex here is 3, 11. So our goal today is to continue to use this vertex formula to graph parabolas from standard form, and then again identify those key features that we reviewed a bit yesterday with vertex form. So example 2, we are graphing 2x squared minus 8x plus 5. Just going to circle that here. So again, I want to start by finding my vertex. So I'm going to use my formula negative b divided by 2a. So in this case, my b value is negative 8, and this is where those parentheses are really helpful, is because a negative 8, or negative 1 times negative 8 gives me positive 8 divided by positive 4, or 2. And then I'm going to substitute in those y values. So 2 times 2 squared. Did I say substitute those y values? I meant to say substitute those x values. Plus 5. And if I were to substitute or use a calculator or do those individual steps along the way, remember order of operations. I need to square that 2 before I can multiply by 2. Just don't forget your order of operations. I get negative 3. So my vertex here is 2, negative 3. So I could start by graphing that 2, negative 3. But just like yesterday, I'm going to use that vertex to make a table or start a table, and I'm going to put that vertex right in the center of my table, right? And use it to find other x values nearby. So this will look really similar to yesterday's work. We're substituting x values in and finding y values. So 2 times 1 squared minus 8 times 1 plus 5. Again, if I'm either following the order of operations or using my calculator there, I should get negative 1. And then remember, I get the, because these parabolas are symmetric, I get another coordinate point for free. So I get 1, negative 1, and 3, negative 1. And then when x is 0, in the back of my mind, I should recognize that this will be my y-intercept. So I could use my shortcut of my c value, but I just want to demonstrate why that little shortcut works, right? If we substitute 0 for x, we get 0 minus 0 plus 5, or simply 5. So 0, 5, whoops, and 4, 5, and then I've got my 5 total points to graph my parabola, and it looks just like that. So from here, if I needed to identify my other key features, I could. My domain and my range, I absolutely could. But for right now, I just want to do one more example where we're going to practice identifying these features. So I'm going to ask you to go to example 3, pause the video and try to find the vertex, and then we'll check back in all together. Okay, so when we substitute these values here, remember to use those negative signs really carefully. We get 4 divided by negative 2, which is negative 2 there. And when we substitute back in to find our y value, we should get 6. So our vertex is negative 2, 6, negative 2, positive 6. My a value is negative, so when I graph this, my graph should open downward, right? And I'm going to use that value here, negative 2, 6, and I'm going to find some other x values and the corresponding y values. Now, when x is 0, I get my y value for free. That's my c value, 2. So I get another coordinate point, negative 4, 2. I'm just going to graph those while I can, negative 4, 2, and 0, 2. And then substituting in, let's go with negative 1. So negative 1 squared minus 4 times negative 1 plus 2. Again, if you're doing these by hand, pay attention to that order of operations. I know that there were a couple of mistakes yesterday related to that. Now, if I needed to, I could obviously plug in some more x values. I would go with 1 or -5, but for right now, I'm just going to worry about getting my 5 points on here and getting the general shape of my problem. So you have a couple more examples here to do. Question 4 and 5 are very similar, right? Using the standard form to identify the vertex, make a graph, and then look at some other features along the way. And then question 6 is asking you to do this without graphing. Now, I would suggest you think about what's the information that you're given, including opening direction, right? And how to find the vertex and how to find the y-intercept. So take a look at these examples, and I will get the answer key in OneNote to you shortly. Again, I really appreciate all of you checking in, and hopefully I'll see you at our next Zoom conference. But if not, you can always reach out via email. I miss you guys. Take care, and I will talk to you later.